So this is just a quick example of some exponential equations, similar to some that are in the maths assignment at about question 6. I'll take the one question and rearrange it into a few different forms to assist with a few of the questions in the assignment. The aim with any exponential equation is to get both sides with the same base. When I look at 3 and 81, I know that the base I'm after is base 3. So I'm going to take that thing that says 3 to the power of 2a plus 1 and just leave it as it is. On the other side, I've got 81, and so I need to know what that is in terms of base 3. So I can think about it as 3 squared is 9, 3 cubed is 27, 3 to the power of 4 is 81. So I get that to the point where I've got the same base on both sides, and now I can look at it and say, aha, if the bases are the same, then the indices must be the same. So that tells me that 2a plus 1 is the same thing as 4. And then I can go through and just solve this piece of algebra. So I can now say 2a is equal to 3, having taken 1 away from both sides. And I'll divide by 2. And a is equal to 3 on 2. Now, if that exact same question were in a slightly different form, well, not exactly the same question, if I had something like 3 to the 2a plus 1 is equal to 1 over 81, then I'd take that question and rearrange it in a similar manner. I'd start by saying 3 to the 2a plus 1, and I'd just get rid of the fraction first by saying 81 to the minus 1. And then I'd think about that in terms of indices, knowing that 81 is the same thing as 3 to the power of 4, and I'd rearrange this now as 2a plus 1. I could take a little in-between step here of turning the 81 into 3 to the power of 4 and leaving the indice on the outside, and then remember my indice law that says that that's equal to minus 4. And so now I have 3 to the 2a plus 1 being equal to 3 to the minus 4. And I can once again compare my indices directly now that I've got the bases exactly the same. 2a plus 1 equals negative 4. And now I'd be taking 1 away from both sides so that 2a is equal to minus 5. And then I'd divide by a, and I'd have minus 5 on 2. If we take another version of something a little bit like that, let's say 3 to the 2a plus 1 is equal to 81 to the a plus 2. Then I'd be taking this question and doing exactly the same thing as before. I'm going to take the question and I'm going to rearrange it to get my bases exactly the same. So I've got 3 to the 2a plus 1 is equal to 81 is 3 to the power of 4, and it's still on the outside a plus 2. So now I've got to multiply my indices by 4, leaving me with 4a plus 8 and 2a plus 1. And now once again I can make my observation about the indices being the same, and then start solving. If I take 2 away from both sides, I've got 2a. If I take 8 away from both sides, I've got minus 7. And so a is equal to minus 7 on 2. Okay, a very last comment on this. If you've got one side has something in it that's a square root, then you'd start by changing that to the same thing to the power of a half, and then you'd take that one bit and make it its other version that we know that it is, and then you could multiply there to just give you that simplification. And any question then that had a square root in it, that would be one of the steps involved in the question.